How to solve linear equations. The concession stand problem. It's the big weekend. Your class is in charge of the concession stand at the homecoming game. After much conversation, you decide to sell hot dogs and hamburgers. You want to maximize the profit. A hot dog gives your class $2 in profit, while a hamburger gives $3 in profit. Based on your class's budget, the total number of hot dogs and hamburgers combined has to be fewer than 100. A hot dog requires 10 minutes to cook, while a hamburger requires 15 minutes to cook. The total amount of cook time that you have is less than 1,200 minutes. Determine the amount of hot dogs and hamburgers needed in order to maximize your profit. So your variables, the amount of hot dogs and the amount of hamburgers will be represented with X and Y. So X for hot dogs, Y for hamburgers. Your objective is to maximize your profit, and the equation to see what your profit is would be how much you make for each hot dog and how much you make for each hamburger. So $2 for each hamburger and $3 or $2 for each hot dog and $3 for each hamburger. So your profit equation would be profit P equals $2 for each hot dog, 2x plus 3y, which is $3 for each hamburger. Then your constraints. Your constraints are the max amount of hot dogs and hamburgers you can make, and also the amount of time you have to make each of them. So both the hot dogs and hamburgers combined, you can only make 100. So x plus y has to be less than or equal to 100. The time constraint, 10 minutes for each hot dog, while you also have 15 minutes for each hamburger. So, and combined, the amount of time for making all of them has to be less than 1,200 minutes. So the 10x comes from 10 minutes for each hot dog, and 15y comes from 15 minutes for each hamburger. It has to be less than or equal to 1,200 minutes. Then what you're going to do is, after you have these, you're going to want to solve for y, so you can plot lines to find your feasible region. So you'll take your first equation, x plus y is less than or equal to 100. Solve for y, so you subtract x on both sides. You get y is less than or equal to negative x plus 100. Then you'll solve for the next equation. 10x plus 15y is less than or equal to 1,200. You're solving for y, so you subtract 10x from both sides. And then you'll get 15y is less than or equal to negative 10x plus 1,200. You divide each side by 15. Again, you're solving for y, so y is less than or equal to negative 2/3 x plus 80. So then you have these slope equations here. So you can, and also the graph is going by tens. So what you'll do is you'll graph these lines. And so once you have both the lines, your feasible region, because it's less than or equal to on both of these equations, the feasible region is the area under both of those lines because it's less than those points. So the feasible region will be this gray area here. And the critical points will be the corners of the feasible region. So all the corners, this counts as a corner, this is a corner, and this is a corner. And also 0, 0 counts as a corner, but you're not going to be making any profit if you don't sell anything. So you can just exclude that one. So the first corner, 100, 0. The second corner, 0, 80. And then the third corner, 60, 40. And these will be your critical points. So to find how much each of these critical points would make a profit, you plug them in to the profit equation. So say you were plugging in 60 and 40 into your profit equation. Well, 60 is x and 40 is y. So you do profit equals 2 times 60 plus 3 times 40, and that equals 240. And so when you plug all of the critical points in, you find that 0, 80, and 60, 40 both have the same amount of profit, and they both have the max amount of profit, because 100 making like 100 hot dogs and no hamburgers only makes $200. So the answer could be both 0, 80 and 60, 40. So you can make either 80 hot dog or 80 hamburgers or 60 hot dogs and 40 hamburgers and get the same profit. So the next problem. A ski manufacturer makes two types of skis and has a fabricating department and finishing department. A pair of downhill skis requires 6 hours to fabricate and 1 hour to finish. A pair of cross-country skis requires 4 hours to fabricate and 1 hour to finish. The fabricating department has 108 hours of labor available per day. The finishing department has 24 hours of labor available per day. The company makes a profit of $40 on each pair of downhill skis and a profit of $30 on each pair of cross-country skis. Find the number of each type of skis that need to be sold to maximize the profit. So what is the maximum profit? Again, you're going to define your variables. So the two different types of skis, which are downhill and cross-country. So X will be downhill, Y will be the amount of cross-country skis. The objective function is profit. So just like the last problem, how much you're making for each variable. So for the downhill skis, you're making $40. For the cross-country skis, you're making $30. So profit equation would be 40x plus 30y. $40 for each downhill, $30 for each cross-country. We're going to skip organizing the data in a table and the constraints. So the constraints are just time. So you have 6 hours for fabrication of a downhill ski, and you have 4 hours for fabrication of a cross-country ski. So, and then for the fabricating department, you only have 108 hours of labor available. So that'll become 6x plus 4y is less than or equal to 108. 108 being the max amount of labor hours, and then so 4y corresponds to the amount of time it takes to make a cross-country ski, and 6x corresponding to the amount of time that it takes for a downhill ski to be fabricated. And then each of the skis only take 1 hour to finish, so x plus y would be less than or equal to 24. So 1 hour for each downhill, 1 hour for each cross-country, and you have 24 hours to finish the 24 hours to finish skis. So you're going to now solve for y on both of these so that you can plot it. And so when you solve for y, 6x plus 4y is less than or equal to 108. You subtract 6x from both sides. 4y is less than or equal to negative 6x plus 108. And then when you divide by 4, you get y is less than or equal to negative 2/3 x plus 18. Solving the next equation, x plus y is less than or equal to 24. You subtract x from both sides. Y is less than or equal to negative x plus 24. So then you'll plot both of these lines, and you should get this. And then both of these are less than or equal to, so the region is going to be below both of these lines. So the feasible region will be anywhere below both of the lines. So this will be your feasible region, and your critical points will be all the corners of this feasible region, again excluding 0, 0, because you're not going to be making any profit off of selling nothing. So your critical points will be 0, 18, 24, 0, and 18, 6. So when you plug these in to your profit equation, 0, 18 would be 40 times 0 plus 30 times 18. You get a profit of $540. So that would be 0 downhill skis and 18 cross-country skis. When you make only 24, if you make only downhill skis, you can only make 24 of them. And so it'd be 40 times 24 plus 30 times 0, and you get a profit of 960. When you make 18 downhill skis and 6 cross-country skis, 40 times 18 plus 30 times 6, you get a profit of $900. So the maximum profit would be made from making only downhill skis. And when you write it in complete sentence, the ski manufacturer will make a maximum profit of $960 by selling 24 downhill skis and no cross-country skis.